Structural isomers show up all over the MCAT. They share the same molecular formula, but their atoms are arranged differently. And those small changes lead to very different chemical and physical properties. The exam tests whether you can quickly identify types of isomers, predict their properties, and understand how chirality and stereochemistry affect biological molecules. Let's walk through the essentials. Structural isomers, the basics. Structural isomers have the same formula but different bonding arrangements. Because of that, they behave differently. New boiling points, new reactivity, even different roles in biology. Chain position and functional group isomers. Chain isomers differ in how the carbon skeleton is arranged. Position isomers keep the same skeleton but shift functional groups to new positions. Functional group isomers go further. The atoms rearrange into entirely different functional groups, like alcohols versus ethers. Tautomerism. A special case is tautomers, like keto-enol pairs. They exist in dynamic equilibrium, switching back and forth. On the MCAT, you'll often see this in carbonyl chemistry and nucleic acid base pairing. Stereoisomers, same connectivity, different shape. When connectivity is the same but 3D arrangement changes, we enter stereoisomers. These split into cis-trans isomers, enantiomers, and diastereomers. Cis-trans isomers. Across a double bond or in a ring, groups can be on the same side. Cis, or opposite sides, trans. Cis-trans differences affect polarity, boiling points, and even biological activity. Enantiomers mirror images. Enantiomers are non-superimposable mirror images. They have identical physical and chemical properties, except in chiral environments. They rotate plane polarized light in opposite directions, and in biology, one enantiomer can be active while the other is inactive or even toxic. Diastereomers, not mirror images. Diastereomers differ at some, but not all, chiral centers. Unlike enantiomers, they have different physical properties, so they can be separated more easily in the lab. Chirality and racemic mixtures. A chiral molecule has at least one chiral center, usually a carbon with 4 different substituents. Enantiomers come in pairs, but a racemic mixture, equal amounts of both, cancels out optical activity. The MCAT loves this distinction. Cis-trans in cycloalkanes. Rings lock atoms in place so substituents can be cis or trans relative to each other. That difference changes strain and reactivity, and it's a common example in exam passages. For the MCAT, the key isn't just memorizing definitions, it's recognizing how isomer type affects reactivity, polarity, or biological function. Be ready to identify whether 2 molecules are structural isomers, stereoisomers, enantiomers, or diastereomers, and know what that means for their properties. With that said, here are just a few of our student success stories. Students who improved their scores and even got into medical school. If you're preparing for the MCAT, click the link below to get started with your own preparation. We specialize in helping students reach a 515+ score guarantee, and we'd love to help you too. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.